Okie dokie, artichokes. No calculator. This is, okay. Average value is integral over interval. I love saying that. Remember that average rate of change is f of b, not f prime. Average rate of change is average slope, which doesn't have to do with the derivative. Okay, just as a little note. So integral from 1 to 4, x to the negative 1/2, have to do it by yourself. Remember, 4 out of the 6 problems are no calculator problems. X to the positive 1/2, flip and multiply, evaluate, 4 minus 1 is 3. Remember, they always write 1 over 3 in front of the integral sign if they're trying to clue you in that it's an average. Okay. The more you can stand to write down of the intermediate steps, the less you're likely to screw up a subtraction. Like you see 4 minus 1, you think 3 on the top. No. All right. Okay. Vertical lines x equals 1 and x equals 4 are going to be bounds. You're rotating around the x-axis. If I take a quick look at 1 over square root of x, whatever that looks like, between 1 and 4, the bottom bound is the x-axis. So this is going to be disks. Always set it up as Hovicki squared minus Hovicki squared. The line you rotate around is always on in both regions. Okay, it's a disk, so the inner radius is 0. X to the negative 1/2 squared is x to the negative 1. The integral of 1 over x. Remember that x to the negative 1, 1 over x, and dx over x should all trigger the same neurons. What's ln of 1? 0. Okay. Average value of cross-sectional areas. Okay. The cross-sectional areas is pi r squared. And the radius is still the same radius. So, and the average is integral over interval. Okay. We already calculated the integral in the previous section, so we don't need to do that. We want to show that the improper integral is divergent, but the average value is, okay, so average value is the limit, okay, so let's see, the integral, you can't, okay, so we're doing these infinity things. So instead of infinity, we're going to write infinity to a positive power is infinite. You don't have to justify that. However, when we do the average value, we have the limit over something that also goes to infinity. Notice you have a higher power in the bottom, so this is going to be 0. Okay, point values. Quick click a button. This is 2 points, 1 point for, let's see, 1 point for integral, 1 point for antiderivatives and evaluations, integral and dividing by interval. This is also 2 points, 1 point for the integral, 1 point for the antiderivative, and the evaluating. This is 1 point for just the answer, because we did most of the work in the previous point. This is 4 points. 1 point for the integral being 2 root b minus 4, and that this is infinite, and I put it down there, but then a third point for the 2 root b over minus 4 over b minus 4, and the fourth point for saying that's 0.